Hi, in this video we're going to talk about parallel and perpendicular lines and how to identify them with both graphs and using equations. So what are parallel and perpendicular lines and why do we need to know what they are? Well, they come up often in geometry and actually they're beneficial to know in real life for a lot of different reasons. So we want to be able to look at and be able to identify them on a graph or graphically, visually, and then also by looking at equations to see are they parallel or perpendicular lines. So graphically, if I'm looking at parallel lines, and they're denoted, which means they're written like these two lines next to each other sideways. And so instead of writing out the word parallel, you can just write it like this. And parallel lines are lines that never intersect. They can go on and on and on forever. They're in the same plane, but they never, ever, ever intersect. Then we have perpendicular lines over here. Perpendicular lines are denoted or written with an upside down T. So instead of writing out the big long word perpendicular, you can literally just write perpendicular, and mathematicians will know what you mean. And perpendicular lines are lines that are going to intersect at a right angle or at 90 degrees. So I wanted to take a look at these graphs and we want to kind of piece them apart and look at the slopes of the lines and the y-intercepts of the lines and see if we can come up with how to identify them based on that information. So I already plotted some points for you, and you should know by now how to find the slope of a graph, find the slope of a line using the graph. So I went ahead and, like I said, plotted some points. So I'm going to go ahead, I'm going to start here on the left-hand side, and I'm going to draw in my staircase. So I'm going up and over, up and over. So the slope of this line, I'm going up to my rise is 2, and my run is 3. My rise is 2, and my run is 3. So the slope of this top line is a rise over run, which is 2 over 3. Now let's take a look at the bottom. I'm going up and over. I'm going up and over. So if I start on the left here, I'm going up 2, counting over 3. Then I go up 2 and again over 3. So the slope of this bottom line also happens to be 2/3. Next, I want to look at the y-intercept. So if my top line here, here's my y-intercept, which means where your graph crosses the y-axis. So here my y-intercept, which we write as a b, is equal to 1. In my bottom line, my y-intercept, I'm actually going down 1, 2. So here in my bottom line, my y-intercept is -2. So just by looking at the slopes and the y-intercepts, what do you think that we could say about parallel lines? We know two things. Parallel lines have the same slope. So under slopes, we're going to write parallel lines have the same slopes. But let's look at our y-intercepts. Our y-intercepts are different numbers. Here this is 1, and here this is -2. If I were to say, okay, I'm going to take this line here and I'm going to change it colors just so you can see this. I'm going to make it blue. So I'm going to take this blue line and I'm going to move it so that it has the same y-intercept as the top line. What happens to it? Look again. So this comes up. My blue line now overtakes it, so it really becomes the same line. They become exactly the same, so we can't tell them apart. So they're no longer parallel. This is called coinciding. So we don't want them to coincide, we want them to be separate so that they never touch. Here they always touch, here they never touch. So we want them to be parallel, which means never intersecting. So in order for that to happen, they have to have different y-intercepts. Different y-intercepts. And remember, we can tell about slope and y-intercept when we're looking at an equation that looks like y equals mx plus b. Okay, let's move on and talk about perpendicular lines. So we're going to kind of examine over here. We'll start with the line that has the negative slope. So remember, slope is rise over run. So I'm going to rise and then run. Rise and then run. Rise and then run. So I'm going down 3, right 2. Down 3, right 2. Down 3, right 2. So my slope of this line is negative 3 over 2. Okay, let's check my other guy. So here I am going up 2 over 3, up 2 over 3, up 2 over 3. So it doesn't get so confusing, I'm just going to write it one time. So the slope of this one is positive 2 over 3. Okay, well they don't look like they're the same. So let's see if we can look at how are they related. So what if you happen to notice, I'm going to zoom this out a little bit so I can write. I'm going to write them down here. So we had the slope of 1, which was negative 3 over 2. And then we had the slope of the other, which was 2 over 3. So there's a couple of different ways that you can remember this. Have you ever heard of the word reciprocal? A reciprocal is the flip of the fraction. You flip over your fraction. So if I were to take my fraction negative 3 over 2, and I were to flip my numbers over literally, if I take my 2 and my 3 and I flip them spots, see how I get 2/3 over here? Here's the only difference. This one is negative and this one is not. So we know that perpendicular lines, they have what we call opposite reciprocal slopes. So that means whatever I have for one slope, I take it, the numbers, the top and the bottom, and I flip them over. And then if it's negative, I make it positive, or if it's positive, I make it negative. The other way that you can remember this is that perpendicular lines have slopes that multiply to -1. So if I was to multiply these two together, I'll do this over here. Actually, I'll do it kind of on the top up here. If I was to take negative 3 over 2 and multiply it by 2 over 3, I get negative 6 over 6, or -1. You can remember it either way. I happen to prefer to remember it as opposite reciprocal, and I'm going to highlight this for you just because I think that's important. Opposite reciprocals. Okay, so I came up with a couple examples below, and I want you to now use these equations to identify if the lines are parallel, if they're perpendicular, or they're neither. So what we want to do is we want to make sure that we solve all of our equations for y. So they'll look like y equals mx plus b. From this point, you can figure out what's your slope, what's your m value, and what's your b value. Remember, for parallel lines, we're looking for the same slope, different y-intercepts. And for perpendicular lines, we only care that the slopes are opposite reciprocals. So, all right, my first guy right here is already solved for y, so that's easy. So y equals 2x plus 5. I don't have to do anything here. I can identify my slope here is equal to 2. Remember, the slope is the number that's next to your x, your m. Okay, and your y-intercept is the number that's by itself, or your b. Okay, now this other guy though, I'm going to have to get y on a side by itself. So in order to do that, I have to add 2x to both sides. And I'm left with y equals 2x plus 8. So my slope is the number that's next to my x, and my y-intercept is the number that's by itself. So here, oops, I forgot to finish writing. My slope right here is 2, and my y-intercept is 8. So my slopes are both 2. So I'm looking for same slopes, different y-intercepts. That is correct. So these lines are parallel. All right, I'm going to look at my next example here. Remember, we want to get y on a side by itself. So first thing I have to do over here, I'm going to divide everything by 3. So I get y equals, now remember, when I divide a whole group by 3, that's the same as saying 2x divided by 3. Each term gets divided by 3. So this becomes 2/3 x plus 3 over 3 is 1. Okay, so my slope here is 2/3, and my y-intercept is 1. Okay, now on this other one over here, I have to get y on a side by itself. So first thing I'm going to do is I'm going to subtract 2x from both sides. Negative 2x plus 15. Then I have to get the y by itself, so I'm going to divide both sides by 3. And remember, this is negative 2x divided by 3 plus 15 divided by 3. So I end up with negative 2/3 x plus 5. Okay, so I'm looking for, are my slopes the same? And are my y-intercepts different, or are they opposite reciprocals? So here, my slope is negative 2/3. So I'm looking automatically here. I got a negative 2/3 and a positive 2/3. Well, one's positive and one's negative. So immediately I know that's not going to be parallel lines, but I have to look, are they opposite reciprocals? This one right here on the left is 2/3. So if it was opposite reciprocals, this should be 3/2, which it's not. So these ones are neither. Okay, last example down here. We want to get y on a side by itself. So I'm going to draw a line down the middle. I need to get y on a side by itself, so I'm going to divide both by 4. I get y is equal to, this becomes x over 4 plus 8 divided by 4, or there's a 1 really right here, so I'm going to write this as a 1/4 x plus 2. So my slope right here is equal to 1/4, and my y-intercept is equal to 2. All right, and I come over here. I need to solve for y on this side. I'm going to add 4x to both sides. Get y equals 4x plus 1. Okay, so now this one's solved for y. So here, my slope is equal to 4. And my y-intercept is equal to 1. Okay, so I'm looking at here and I say, all right, ooh, now they're opposite. This looks like they're, or not opposite, this looks like they're reciprocals. So remember, a number when it's just a whole number has really a denominator of 1. So here, the slope on this left side is positive 1/4, and over here it's 4/1. So I took the reciprocal, I took 1/4 and I flipped it to be 4/1, but they're both positive. In order for them to be perpendicular, one would need to be positive and one would need to be negative. So in order for that to happen, this would have to be negative. But because it's not negative, these are also neither. Okay, let me know if you have any questions. Good luck.